Hello, hi everybody. Miss you guys. How are you going? I hope you're well. Yes, you listened to Ian Miller's video so far, and I assume around today you probably complete 17, video 17. I asked you to watch video 17 and 18. 18 is a bit longer, so I assume you did your first lesson is 17, and then you need to continue 18 through the two lessons. Okay, and I'm going through some of the exam questions to help you and you're able to solve it or at least understand based on you watch it and studied it till lesson 17 on that video, Ian Miller's video. Sounds good? Okay, hopefully this help you and you understand what's going on. Hold on. Okay, so can you go through question, can you copy the question 25, 26, and 27? So 25, 26, 27. Can you copy that in your exercise book first? You pause it and do that first. And you try first. Well, hopefully you're able to do a little bit of question. But remember, this is a given question. Okay? Complex number isn't too difficult. Okay? I mean, as long as you understand the concept, you should be fine. But okay, hopefully you copy everything and try it. Okay, after you start to watch this video, after you complete that first. Okay, and let's do that together. Question 25. Here we go. Given Z is complex number, isn't it? Yeah. Z is complex number such that argument angle of Z equals theta and modulus the length of Z is R. Let's go back and check that. Do you remember that? That is R, that's the theta, isn't it? When that's real and imaginary. When Z, we use Z instead of X for complex number, is X plus Y, I. So that X part, and that's the Y part. X part is real part, Y is imaginary parts. Okay? You guys all happy with that? Yeah? And write an expression for such of this, that in terms of, okay, I get that. In terms of R and or theta, which means I need to continue. This is a polar form, isn't it? I need to continue to use the polar form. If you're not sure, go back to some videos, okay? Rectangular form and polar form. Previous video, I think, 15 or 16. And then, so based on that, Z equals R and, good job guys, cis theta. I know this one. And they say, look at it. What I want to know is argument for Z cubed. That's what I want to know, isn't it? So before we knowing argument, we need to know what is this. So let's start from Z. Z equals R cis theta. Let's try to cube them. So Z cube equals, can you do that first? The lengths become power 3. Good job. Cis, what about the angle? Same? It goes to index? No, it's 3 theta, isn't it? Good job. And then all I need to do times 4 Z cube is 4 cis. You guys happy? Yep. That's the angle. So I just times 4 for that. Yep. So that is this times 4. And therefore, argument angle of 4z cubed equals, what's the argument here? 3 theta. And also they ask you to get modulus of 4 times z cubed equals 4 r cubed. That's modulus, that's argument angle, isn't it? Yeah. So that should make sense for you. So I just did it, question 25. Hopefully that makes sense. Let's continue. Next question. Question 26. Find all complex numbers z such that that's the given, isn't it? The two factors given. And in this case, oh, I know I'm dealing with, okay, imaginary parts. Z, okay, modulus is 3. I get that. And I'm getting Z. Z equals, I don't know. So I'm starting with A plus BI. You can write down X plus YI. Doesn't really matter. As long as I get A and B, I can get what is Z. Isn't it? So that's your starting point. If you don't know, always start from Z equals X plus YI or A plus BI. I'll just write down A plus BI here. Is that okay? Yep. And that's given. So imaginary Z, complex number. Imaginary part of the complex number is 1. Therefore, where is imaginary part? B part, isn't it? That whole thing is imaginary part with I. So B equals what? 1. B is 1. Imaginary part is 1. So I know, based on that, Z equals A plus 1I, therefore is I. So I use that part, done. All I need to do is next part. Z is, I said A plus BI, I know B is 1, so it's I minus 2I equals 3, A minus I equals 3. Modulus of this complex number, when we get the modulus, do you remember that? A, B, you can use X and Y or X, Y, if that is X and Y, okay? Yeah? How do we get that? A squared plus B squared, square root, wasn't it? Therefore, in this case, A squared plus 1, 1, minus 1, minus 1, 1, square root equals, so I'll get the modulus part, the length, modulus, which is 3. Therefore, A squared plus 1, square square, 9, A squared, 8, A equals plus minus square root 2. Therefore, Z equals, A could be plus, oh, it's 2 root 2, 2 root 2 plus I, or minus plus I. That's how you get. If I draw that real and imaginary part, we were getting, I know imaginary part was 1, wasn't it? So imaginary part was 1. This was 1. So it could be here or there somewhere. And I'm looking for possible Z. I could get this or that, isn't it? Yeah. And R, next one we know, modulus is 3. So that could be 3. Distance could be 3. So all I need to get was, this is 1, this is 1, that distance either 2 minus 2. That's what you get, isn't it? Yeah. So possibility is this or that. I can draw it as well, or we can just get it from here. If you're able to just go there directly, I'll probably solve it that way though. Yeah, I'm just showing you two different things here. Okay, next one. Question 27. Two roots of polynomial, this is all algebra question, really, at this point. There's two roots. When you say roots of polynomial equation, like this, remember that? Like P2 equals 0, P3 equals 0, and I know, based on the factor, when I use that, that's a factor, isn't it? It will make 0. Same thing with complex number. So they said Pz, I use z instead of x, equals 0 when 2i and 5. Write a suitable polynomial P. Okay, I get that. A complex numbers. Okay, then based on that, z instead of x, z minus 2i, z, 5 is a root, therefore z minus 5, isn't it? I know, that's given information, isn't it? Equals 0, yeah? So that's the factor, so I can write down. When I expand it, you should get z squared minus 5 plus 2 I z plus 10 I. I have that. This is complex numbers. Okay? We can get the possibility of complex number here. Isn't it? So we're getting the suitable polynomial B, and that works for this. Yeah? Or we looking for real numbers. Go and find another possibility. Okay, when 2i is a root based on conjugate theorem, according to conjugate theorem, what is root as well? Minus 2i. So now I have three roots, isn't it? 2i minus 2i, 5. You need to write it down. It is according to conjugate theorem, if 2i is a root, minus 2i is also root. Okay, so now I have three roots here. So I write down Pz equals z minus 2i, z plus 2i, z minus 5. When you solve it, I'll just write it down the answer. Okay, we got the real number here. No i's there. So that's what they're saying in this case. We can get both and then check it. Are there complex number form or real number here? Good? All written as real number. All good? You guys happy with that? Yep. Just using conjugate theorem here and root theorem. We learned it from method 3. Now it's just complex number. That's the only difference. So we're not able to solve those questions yet, okay? But at least still able to solve 3 questions out of it. Done that. Hold on. Let's go next one. Do you understand so far? Yeah. If you're not sure, you need to watch videos again. Okay. Question 25, 26, 27. So 1, 2, 3 question. You can do it. Yeah. You're able to do 3 questions. All right. I'll wait a little bit. You go through this first. Copy that and try to solve it first. Spend enough time to continue those. Can you pause it? All right. I assume you've done it. Spend some of your time. Question 25. Question 25. Given that 1 over W equals, it's all algebra question. It's just algebra question, really. Express W in rectangular form. Well, rectangular form is x plus yi form, isn't it? Yeah. Real imaginary parts. Yeah. So all I need to get is W, isn't it? Based on that, it's already rectangular form. So W, so W is there. It's like we're getting 1 over x. Yeah, it's like 1 over x. Something like this. Same thing. What do we do? We get and try to get x, isn't it? Out of it. Yeah, it's algebra. Simple enough. So we'll do exactly the same thing. 1 over W equals left hand side and right hand side. When you solve it, that has to be the same, isn't it? Yeah. So I'll just what's a common denominator here? Minus 1i and I. Therefore, I times 1, I 1 minus I. You happy with that? And then cancel that out. 1 minus I. Expanded minus I squared. And then I squared is minus 1. So minus 1 plus 1. 1 over 1 plus I. I just swapped it. Yeah. Which is same as what? 1 over W. We're lucky enough, we don't have to times W each here. In this case, since 1, 1, they're the same. All I need to do, comparing this, W equals 1 plus I. So I've done it. W equals 1 plus I. Simple enough. And the question's pretty simple for complex number. Question 26. Quite often just approach like an algebra question. For any complex number, z equals x plus yi. You can write down iy, it doesn't really matter. And with complex conjugate, x minus yi conjugate, yeah. And find argument z plus conjugate z I. So that's what we have, isn't it? That's what they're asking. So all we need to get before argument, we need to know z plus conjugate zi. What is z here? X plus yi plus I. What is conjugate z? X minus yi. You happy with that? Yep. And then we expanded x plus yi plus xi and I squared minus 1, so minus minus plus y. So I rearrange this with real parts plus imagine excuse me okay, x plus y I. You understand this one? So z plus z equals this. We get that, isn't it? That is real parts, that is imaginary parts. Yeah? I mean, okay, they keep using x and y, but let's say this is a plus bi. You get that? A plus bi. In this case, x plus y, they are the same. So it's an a plus ai situation, which means this is a, that could be the a. That makes sense? Anyway, let's continue. So they said we need to get argument z plus conjugate z I of this argument x plus y plus y. How do I get the argument of this? That's the real part, that's the imaginary part, isn't it? When we know real part and imaginary part, how can you get the argument? Let's say this is y and x. I'm talking about the concept. When Ian or I told you the concept is this way. That's imaginary. That's real. Yeah. Argument of that argument equals y over x, wasn't it? Tan theta. That's how you get tan theta equals y over x, and theta equals arctan of y over x. Good. In this case, tan theta equals x plus y over x plus y. X plus y, that's the length they have, imaginary parts, real parts. Sorry, real parts, yep, that's the real parts. And that part is imaginary parts. Y over x, I write down x plus y, x plus y. So when I say x and y here, this is more our concept. It's not x, y here. Okay? You get that? Yeah. So theta equals arctan x plus y, x plus y. When you get that, arctan, same thing. So arctan 1. Let's go back. Arctan 1. Theta equals arctan 1 when x plus y is not 0. Isn't it? If x plus y equals 0, that will become 0 and 0. So undefined. You need to write it down. You need to consider, as always, the bottom part 0 is everything becomes 0. And if it's not 0, angle theta is 45 degrees, pi over 4. You can get it from here. Yep. That means x plus y if this was x plus y over x plus y, wasn't it? y over x. Usually, that y parts, this is x plus y, that is x plus y, angle theta, which could be pi over 4. When what? X plus y is positive or bigger than 0. Let's say for positive. That's most of you guys can see. However, we can see another case. We don't know what is x and y, isn't it? That's another case we can get. That angle is when x plus y and x plus y's are negative. So x plus y, so I can write down when x plus is smaller than 0, negative, negative, and negative. I still get the angle there, which is pi over 4, isn't it? That angle is pi over 4. However, we always start from here, isn't it? Positive, negative. So how much we move? Pi. So minus 3 over 4 pi. The whole thing is minus pi. So we can get that. Minus pi plus, took that out. So we got minus 3 over 4 pi. So I'll write down if x plus y is bigger than 0, we got pi over 4. When x plus y is positive and positive, yeah. And if x plus y is smaller than 0, negative parts and negative parts, yeah, then I get minus 3 pi over 4. And you can write down this. I think in that exam they gave you full marks for both. I'm not sure exactly, or give the full marks for this. But you should write down both cases. Yeah, you must know both cases, since we don't know what is x plus y. Okay, question 27. Question 27. If z equals r cis theta, polar form, find all values. So we need to find all values of, we're getting argument of z, such that, but that is, when we square that, is real. Okay? So, when I deal with z, rectangular form is x plus yi, isn't it? Or I previously used a plus bi. But in this case, they're already given. I'm using polar form. So z equals r cis theta. It's a good starting point, isn't it? And they said z square is what? Real number. Well, what does that mean? Let's just go. What is z is r cis theta. So z square is r square cis and excellent 2 theta. Did you get that? And they said this is real number. Let's break it down. Cis means what? R square. Yep. Cosine 2 theta plus good r square. Cis sine, cosine and sine. So cosine and sine. Well, cis is cosine, I sine. Cosine, I'll write down I sine. I can go anywhere, doesn't really matter. They say this z square is real number. When do we have real number? When imaginary part become what? Good. 0. Then that is real. Isn't it? Yeah, real number. So r squared sine 2 theta equals 0. And we're dealing with what? Argument, isn't it? Argument. Angle. When do we get this is 0? Sine 2 theta equals 0. When do we get this? Let's think about 2 theta equals 0 when? Continue. Well, let's from here. Minus pi 0, 0, and it continues, isn't it? And in this case, pi 2 pi continue, isn't it? Yeah, but we're dealing with I want to know, they said we need to get the theta. Yep, theta equals divided by 2 minus pi over 2, 0, pi over 2, pi. So I did divide by 2 here. Continued. Argument, angle of z equals what then? Angle of z is when that's 0, yeah, and pi over 2, we get that, yeah, and pi, good, makes sense, and then that only we covers 0, pi over 2, pi, we cover 1, 2, 3, we need to go the other way, which one was minus pi over 2 here, and that, which is already we covered pi, isn't it? So the possibility is this 4 in our angle, okay? The other ones is repeating, so we don't have to write that down. You guys happy with that? Yep. I know it's much easier face to face, but we don't have many options here. So we covered question 25, 6, 7. And let's do one more question. Another question from a different year. Without using your calculator, simplify. 3 minus 3i squared, 3 plus 3i. Question 25. Can you write it down? In this one is the area, so you need to learn eigenplane more. Cubic root, this next video. You're probably only able to solve 25. Okay? 25. Can you write it down and do it first? Pause it and do it. It probably doesn't take too long. It's algebra question, isn't it? Algebra question, yeah. Squared. Write it down. And then, when I do it, I got 18i over 3 plus 3i. Okay? Minus 18i divided by 3 plus 3i. Division for complex number, what do you need to do? Conjugate of denominator. When you solve it, I will get cancel that out. I deliberately make that way. Minus 3i minus 3. Should write down minus 3 minus 3i. Isn't it? Minus 3 minus 3. Yeah. Get that? Hopefully Also, not for that question, but you need to able to change from rectangular form to polar form. Okay, cis r cosine plus sin I. Okay, make sure you use able to use that as well. So hopefully those exam questions give you a bit of sense how exam question look like it. Make sure you try that question again at the end of this week by yourself. Okay, hopefully you're able to do that now. All right, I'll finish the video here. Ian Miller's video will explain the concept enough, okay, as long as you watch several times. If you still have question you don't understand, please email me. I can give you a call and explain it. I don't have to make same video again. But other than that, I will upload more exam-like questions, which covers this week videos, maybe early next week as well. And then after that, I'll upload some exam questions so you can do it as well. All right, thank you very much. We'll see you soon.